बिस्मिल्लाहिर्रहमानिर्रहीम रब्बि इश्रह ली सदरी व यस्सिर ली अमरी वहलुल उक़दतम मिन लिसानी यफ़क़हू क़ौली। O my Lord, give my word depth so that what I'm trying to communicate should reach my audience and they should understand what I mean. So this is another example of CAN layer. This is example 2.10 of page 69. Now this is a typical example of a tandem axle in which there are four wheels and how this is how we can show you how this stress and strain can be calculated in this example. So so this figure shows in full depth asphalt concrete 8-inch depth subject to a tandem load of 18,000 pounds, having contact pressure of 67.7 psi, and if the elastic modulus is 150 psi and that of subgrade is 15,000 psi, determine the critical tensile strength in the asphalt layer. What I mean is 18,000 we have, since there are four wheels, so we have divided it into four. That's why on each of those wheels there is 4,500 pound load. As far as the spacing between the dual concern, this is 11.5 inch, and between the axle, this is 49 inch. So on this part, it is 49 inch, and from on this point, this is 11.5 inches. We need to calculate. What we will do is we'll calculate the tensile strain at the bottom of this wheel. We can take any wheel, but for this convenience, we'll take at this wheel. And this, how I'll show you how to do it in KenPave. This is a two-layer pavement. So that's why we'll go to the KenPave and we'll so what we are going to do is, this is our example. So we'll use again these four parameters: layer input, layer Ken layer, L graph, and editor. So once you do it, the next thing is we'll open this file, and this is example 2.10. So we'll open this file and we'll put it there, and this is, nothing has changed from the previous problem. Even line number of layer is 2, and all the other things are same on the first page. Then we go to the next page. We have to import Z coordinates. So the depth is 8 inch. That's why we have put 8 inch over here. The next thing is they will ask you about the thickness. So we have 8 thickness and Poisson ratio 0.4 that is been given to us. The Poisson ratio of the subgrade is 0.5. Then we'll give the layer modulus. This is 15,000, 150,000, 15,000, as we know from our problem. In the load group, now this is a tandem axle. So we'll say, it says if you have 2 for tandem axles and 3 for tridem. So that's why we have write 2, because it was tandem axle. The contract radius we have already calculated in the previous example, 4.6. We know that the contact pressure is 67.7. The spacing between the dual tire is 11.5 inch, while the spacing between the axle is 49 inch, and the number of response point is 4. And when we double click this NR, we'll give this example. The first is 0.8. We'll calculate all these along this coordinate, and the third one is the diagonal coordinate. So 40, 50.42 and 8. How this 52.50.48 is calculated is simple. What we have done is we have taken, We have used Pythagoras theorem 11.5 square for 59 point range. So this diagonal value is 50.42 that I have shown here. So once we have done this, then we go to the scan layer, save that file. We go for the can layer and we run that. And this, this our magical message that everything has been analyzed with all those integration cycles, and we have what's the file is stored in our C drive with this name. Now, once you do that, now we go to editor and we'll open this file, and we found that it has summarized what we have given, and it says 3.705 into 10 power minus 4. If you look at this book, at the example, this is 3.03. So more or less, there is no much difference in this. So this is how you will solve the can layer problem, example problem. So this is it. I hope you have understood this KenPave software. Just keep visiting my channel. I have other examples solved for you as well. Thank you very much. Take care.